Okay, this video is going to explain how to do a couple of different calculations in the gravitation unit. So this is for gravitation and astronomy. It's a review for the Quizzam. Okay, we are going to practice by using Newton's universal law of gravitation, which is here. In order to solve this problem, you can go ahead and pause the video, get your packet out, or if you are on an iPad, open up your packet in Notability and find the astronomical data worksheet so that you have all of the information that you need to solve this problem. We are going to solve the force between Jupiter, which is found over here, and the Sun. So the variables that you're going to need are G, which is 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared. You're going to need the mass of the Sun, which is 1.99 times 10 to the 30th kilograms. You're going to need the mass of Jupiter, which if you look at your data sheet, the mass of Jupiter is 318 times the mass of Earth. So that's 318 times 5.98 times 10 to the 24th. And you're going to need to know the radial distance between Jupiter and the Sun, which is r. On the astronomical data sheet, that is called the mean distance from the Sun. And for Jupiter, that is 778, and we're going to do times 10 to the 9th because we need that in meters. Now I have an additional video link that you will find also on the website or in your iTunes U if you have an iPad that shows you how to punch that into the calculator. But you need to plug all of this into the formula, and when you do that, you get an answer for the force that is 4.17 times 10 to the 23rd newtons. So make sure that you punch all of this into your calculator and see that you come up with this answer. The next thing we're going to try is near-Earth calculations or near-planet calculations, which is little g. And the formula for little g looks like this. And you can plug in information for any planet. We'll use Jupiter again. So you're going to need to know the mass of Jupiter, and you're also going to need to know the actual radius of Jupiter. We're not talking about the distance between Jupiter and the Sun now. We're talking about the actual planet itself. So again, the mass of Jupiter is 318 times the mass of Earth, times 10 to the 24th. And the radius of Jupiter, you're going to find that by looking on your astronomical data sheet for equatorial diameter. And you need to make sure that you convert that number into meters and then divide by 2. Because we're taking a diameter and making it a radius. So in this case for Jupiter, the equatorial diameter that I'm finding on my sheet is 143,000 kilometers. So I'm going to add 3 more zeros to turn that into meters, and then I'm going to divide that by 2. That's how I will find my radius. I'll solve this on the next slide. And what you should get when you solve for G is you should get an answer of 24.8 meters per second squared, and this is what it would look like if you were going to set it up. 6.67 times 10 to the minus 11th times the mass of Jupiter, which is 318, times the mass of Earth, 5.98, times 10 to the 24th. And then all of that goes over the 143,000 with the extra zeros because we're converting from kilometers to meters. You have to divide that by 2 because we need the radius, not the diameter. And don't forget to always square that. When you plug that all into your calculator, this is the answer you should get. So try it out and make sure that's what you get for the surface value of G for the planet Jupiter. The other thing that I want to make sure that you are taking a look at for this Quizzam is the life cycle of stars. For Mrs. Page's classes, I'm going to ask you about that and ask you to tell me about what happens to a star, how it's born, how it lives, and how it dies. So take a look at this slide and make sure that you have a general understanding of what happens for the 2 paths that stars can take when they start from nebula and make their way up here, or if they make their way a smaller star down this path. So pause the slide and make sure that you have a general understanding of what happens there. And the last piece that I want you to know about is this HR diagram that we did in class that you colored in. And again, some questions I want you to be able to answer is, or are, temperature. What does temperature determine about a star? Does it mean that it's a bigger star or a smaller star? Color, size, what does it have to do with? And so make sure that you take a look at that, temperature. And the other thing is luminosity, the brightness of stars. Is it big stars, little stars? How do those run? So be able to explain and take a look at your HR diagram and know just the general idea of where stars fall.